Alright, so the first step here is once you turn the machine on, you have to reset to delete all the errors. And then following that, then we can begin the power up restart process. So it's very similar to the mill where you first start off just by hitting power up restart. Simply it brings up a menu here that tells you what it's going to do first. Like for instance, if you hit T, like the letter T, it's going to zero out the turret and turn the turret around to zero all the tools out. And then if you hit A, it's going to zero out the X and Z axis. So number one step is you can either hit T, or if you hit A, it'll do both, one after the other. The first step though is to hit 5% rapid, and then make sure you're not going to hit anything as it's going to tool change right off the bat. So if you go ahead and hit A and have your finger on feed hold in case it decides to collide against itself, you can actually stop it. And then now we just wait while power up restarts and just watch to make sure we're good. Alright, so after power up restarting, the first step is to open the doors and clear all the errors. Following that, then we can handle jog it over. Simply all that does is move it over here now to where we can start zeroing our tools and our part. So first step to do that is you hit handle jog, and then you can select your increment right here. So like here is the 0.1 increment. Simply that means for every turn of this dial, it's going to move 0.1 of an inch. The Haas guy recommends you never ever use this increment simply because the servo lags behind it, and you can easily crash the machine. So best principle is to always only use the 0.01 increment. The funny thing is these actually move at the same rate. It's just recommended you never use the 0.1 simply because you will crash it. So first thing we'll do is we'll select handle jog, our increment, and then our axis, which is over here on the Z, which is left and right. And then we'll begin to jog it over and seal our parts.
There you go.
Alright, so the first step after you move the turret over is to set your touch-off tool. Simply you can just set that on the side of the turret or the spindle itself, and then we'll begin to jog the actual tool over and touch off on it. So you can jog over in the Z and then in on the X. And as you get closer, go down in increments until you touch it. So you want to just touch with the very corner of the tool. See there, the light came on, we're touching it. So I'll back off, and I'll go to the finest increment and go one click at a time until we see the light. All right, so that is the very first. If I turn the wheel one more notch, the light comes on. If I turn it off, or turn it one more the other way, the light turns off. So we're gonna leave it on the very first one where it turns on the smallest increment. The first step, what we do over here is make sure we were on the smallest one, and we see that it was verified that the light turns on and off with one click. The first step we'll do is make sure we're in our offsets page. You can hit the offset button here, and you automatically are defaulted to the tool offsets. That can be noted as it says tool up here that's highlighted. We want to highlight tool number 1, which is what we're using right now, and you want to hit Z face measure. So what that did is that changed the Z geometry block right here, and what it does is it tells it where that tool is relative to the actual plug. Alright, so after touching off and hitting Z face measure, the next step is we got to go to our next tool. So you go back to handle jog, select your Z axis and your increment. Like I was saying, never use 0.1, only 0.01. So we'll select that. You see it's verified. And then we'll jog away. If you want to catch this, we jog away to a safe location. So we're away from the actual spindle itself, and we're away when we look at the doors. We're not going to hit anything in there because you can actually hit the door relatively easy. We'll go to MDI now. So now to do a tool change, we want to go to tool 2. So what we'll do is we'll go T2, type that in the control down here, make sure we're in MDI, and you simply have to hit turret forward or reverse. Either one will change it to tool 2. Before we hit that though, we want to make sure we're on 5% rapid and have our hand on feed hold, just in case something goes wrong, we can stop it right away. So now that we're all good, I got my hand on feed hold, 5% rapid, we can go ahead and hit turret forward, and it will tool change to tool 2. We can open the doors up, and there we go. So the next step after that is to go back to handle jog, and then we'll jog over with this tool, and now touch it off against the touch off tool once again. See, there we go. Now I'll decrease my increment once again. So now we are in the 10,000ths increment. If I go one more click, the light turns on, one the other way it turns off. So we'll leave it on the very first one where it turns on. Then I'll hit Z face measure. Okay. So once again, this is setting that tool off of that plane to where all the tools are set. However, for this tool, we're going to use this as our tool that we're going to set our operator value. Now, what this does is it allows us to be able to measure from that touch-off tool to the end of our part. And that allows the machine to do a work shift offset to be able to actually offset from that distance of where that plane where all the tools are set to where our workpiece is. So now how we do that is we first, with tool 2, after we hit Z-face measure, we'll go to position. Okay, it brings up the position of the machine itself. So here is our position relative in our program, or G54. This is the distance to go to what the program's calling out, which is irrelative for what we're doing. This is the machine coordinate system, which is referencing the entire machine system. And then lastly, we have what's called the operator. Now this operator is an internal measuring device within the machine that allows us to origin at specific points, move the turret over to a certain spot, and it basically tells us the difference in length or distance between the two. So highlighting the operator here, for tool 2, we only have to do this for this tool. You highlight the operator, make sure the Z is highlighted. You do that by selecting the Z axis. You can select the X axis or the Z axis. In the case we want the Z done. And what we'll do down here is we'll hit origin. So hit origin, makes that number 0. So now if we go back down here, we can see if I go to handle jog, select Z, and our increment, if I move the turret over to the right about there, and we go back to position, we are exactly 5.1 inches away from where we touched off our tool to where it is now. So essentially what that operator did was we origined it right here, and I moved it over by handle jogging now, and it tells me the distance from the area where I origined it. So essentially it's 5.1 inches from there to there. And we'll use that later when we set our work shift offset. All right, so now that we did tool 2, the reason why we did origin our operator on tool 2 is it's a finishing tool. Simply you want to do it on your finishing tool because it sees the least amount of wear, and it generally gives you the most accurate results. So we picked tool 2 in this case. We don't have to do that for any of the other tools, but we just have to keep in mind that tool 2 is the one that we're going to use to set our work shift later on. So next, after doing that, we'll move on to tool 3 and go ahead and zero that, which in this case is a threading tool. So what we'll do once again is we'll make sure we're at a safe location, the tool change when I shut the doors, which it appears we are. We're not going to hit the doors, coolant hose, spindle, or part. So once again, go to MDI and we'll type in T3, make sure 5% rapid, have my finger on the stop button, and we'll go ahead and either hit turret forward or reverse, and we tool change. All right, so now we're there once again. Now I can go to handle jog and I'll jog it over. I need to go back a little bit and over. So a threading tool is probably the hardest tool to actually zero. Simply because you have to zero off of the exact point of the thread tool itself. So we'll just jog it over until we get relatively close. All right, keep going. You gotta be real accurate with it. All right, so that's the very first click to where it lights up once again. So like all the other tools, once again, we'll just hit Z-face measure, making sure we have our tool 3 highlighted and our tool offsets here. If it's not, once again, just hit offset and it brings you back up. And then you make sure you're highlighting tool 3 and you just hit Z-face measure. And we can see there, it changed that number in the Z geometry. Once again, we're setting all our tools off of that plane of where that touch-off tool is, and then we'll shift it over to the work itself using that operator value we set. All right, so now that we set all 3 of our tools that we'll be using to start this part, the next step is we actually need to tell it where the workpiece is itself. So to do that, we want to use the tool that we set the operator value on, which was tool 2 in this case. So first thing we need to do is once again move it away by going in a handle jog, selecting our increment and our axis. We'll move it over here to where it's safe. We know it's not going to hit anything. This machine has no brain. It can hit relatively anything from the door, spindle to the tailstock, so we want to be sure. So we'll go back to MDI, select tool 2, just typed in T2, and then hit turn forward or reverse, being ready to stop it if something goes wrong. And there we are. We're back to the tool of which we set our operator value with. So in order to now tell it where the workpiece was relative to that touch-off tool, what we need to do is we need to go back to handle jog. We'll jog this in a little bit, and we'll jog over just to where we're real close to the part here. Being careful not to hit the part and break the tool. All right, so now we're about 1/8 of an inch away. The first thing we want to note is how thick our feeler gauge is. In this case, it's 14 thousandths of an inch thick. So what we'll do is we'll just keep getting smaller increments until we get close. Right, and we'll use our feeler gauge to feel when we start getting close and it starts to bite into the feeler gauge. All right, so there, I just kept going one increment at a time in the z-axis in the negative direction, which is that way. Z-axis positive is that way. So we went until the feeler gauge starts to bind. So that means we're touching the actual part itself. So from there, we'll come over to our control panel. We'll go back to our offsets, right? So our offsets are now brought up. Instead of messing with the tool offsets like we did earlier, we're gonna hit this button right here, F4, and it'll bring us over to our work offsets. You could also do this by clicking up here on the work little tab. F4 is just a shortcut. And then we'll scroll down here to our actual G54 line, and where it says Z-axis. See there's a number right there? This is from the last time the machine was ran. What we're gonna do is, since we're using tool 2 right now, which is the tool that we set our operator with, we're gonna go down here, look at the value of our operator. Currently it says 4.8066. Now what that means is currently where this tool is, we are 4.8066 inches away from the actual touch-off tool, if that makes any sense. So basically what we're doing is we measured the distance from the two, and we're gonna type in that number right into that line on G54, the Z-axis, to shift all our tools from that plane over to the end of our part. So now the machine knows, okay, when it references 0, all the tools reference off of this one plane at the end of the part. So we simply do that by looking down here at our operator, the value of the Z in our operator, type it in, so 4.8066, right? We have it down here in our control. Make sure we're highlighting the Z-axis in G54, and then we'll press F1. F1, what it does is it will overwrite whatever value's in there with the value we typed in, and you notice it brought up a warning here. Now, setting 142, what it means is you're changing this number by a very large amount. Are you sure you want to do that? In the case of what we're doing, we do want to do that. So we'll go ahead and just hit enter. And now you notice that this value here and the value down here in our operator match. So now what we need to do is we need to actually, we were using a feeler gauge in between our part and the tool itself. So we need to subtract the thickness of our feeler gauge. Now you do that by, once again, highlighting that G54 Z-axis line and going negative 0.014, which is negative the thickness of our feeler gauge. You hit enter, and you notice it subtracted that value from it. And now we have actually zeroed all our tools and zeroed our part relative to where we set all our tools.
I'm ready.
All right, so now that we set all our tools, I did want to bring up one quick thing. So what we did is, if you go back to our offsets, your tool offsets here is, it basically accommodates for each individual tool length, and it applies it for that specific tool. Meanwhile, when we set everything and shifted it using our work offsets, it applies it globally to each tool. So essentially it shifts all the zeros of each tool when you run your program, which is what we want in our case because it moves it to the end of the part. So now that we've done that, we want to actually check to make sure our tool here is at Z0 when we tell it to go to Z0. So what we'll do is we'll go back to handle jog. I'll come back out in the X. So when we make sure it moves in the Z, it'll be completely safe. Next thing you do is you shut the doors, and we'll go to MDI. So we're in MDI here, and we'll go ahead and erase our program, and then we can type in our program to check our Z. We have a little cheat sheet up here, but the program to do it is G00, G54, and then we want to go tool, so T202, T02, or T202, and then we want to tell it go to Z0. And we'll hit enter, and it puts it up here in MDI. Now that means G00 means go as fast as you can in rapid. G54 means call out or offset 54. T202 means use tool 2 and height offsets 2. So height offsets 2 are these offsets for tool 2 right here, which are what we set all on that origin of that touch off tool. And then Z0 is the location of where we're telling it to go to. So make sure it's at 5% rapid, and then we'll go ahead and hit cycle start, and we can see it moved over that way roughly about 14 thousandths of an inch, and we can jog it in here, and if we look, we're right on the end of our part, which is perfect. Now you can check this for every single tool. The way you would do that is you tool change it to the tool you want, and then in MDI here you can change the T202 to whatever tool numbers you're using. So it could be T303, T404, T101, it just depends. So I recommend doing that for every single tool, and check your Z's. So with that saying, the next step here is we need to set the X of each tool. So now we want to make sure we're in a safe location, because we'll change back to tool 1 just to start at an even number. So make sure in MDI, type in T1, go ahead and hit turret forward, and we'll tool change back to tool 1. So we'll open our doors up here, and what we'll do is we'll handle jog over. Now this is a pretty critical step. We'll get our feeler gauge back out again, make sure we have one that is in good shape. And what we'll do is we'll simply scroll handle jog in. And now we're using a 12 thousandths feeler gauge. We're getting really close. I'll start going slower and lower increments until we start to feel it pinch. So we're starting to feel it pinch. So awesome. So as we were saying before, we got cut off by running out of time on our camera. What we did was we had jogged the actual part in, or the actual turret into the part on the x-axis here, until our feeler gauge here, which is 12 thousandths of an inch thick, started to bind with the tool we had selected. So as you can see here, we were jogged into 10 thousandths at a time until we started to bind. And what we did from there is we need to tell it where all our tools are in the X direction. So simply what we did was we came over here, we hit X diameter measure, making sure that we were highlighting our tool offsets for tool 1. And what we'll do is it brings up this box here that says enter a value for diameter. Now what we need to do, since lathes work in diameter, we need to actually input the actual diameter of where we are relative to the spindle center of the actual machine. So what we did that by, or how we do that is we know our stock here is 1 inch in diameter and our feeler gauge is 12 thousandths of an inch thick. So in this case, the actual diameter of where we're sitting, touching against that feeler gauge is 1.024 of an inch. So what we'll do is you just type in 1.024 and hit enter, and it changed our X geometry of our tool. So now it knows where tool 1 is in the X direction. And now simply, you repeat this process for every single tool in your turret. So you can repeat it for tool 1, tool 2, and tool 3, and then just do, and be sure to do safe tool changes in between. All right, so now that we touched off tool number 1, as I was saying, you repeat this process for every single tool, just being sure to move it back in a safe location, and then doing your tool change and making sure you're not going to hit the machine itself. So here we are. We're going to go ahead and just jog it back, make sure we're in handle jog, and we'll jog it away from the part, grabbing our feeler gauge, and we'll grab it. Go ahead and just keep jogging over here until we're in a safe location. And once you've repeated this actual process of zeroing both the Z and the X for every single tool, you're now ready to run your program.
Start.
All right, so now that we've set all our tools in the X and Z, and we set our work shift offset relative to that touch-off tool, we can now run our program. So now I have all my programs loaded on this flash drive here. So we can bring up our programs itself by hitting list program, making sure our flash drive is mounted, which there seems to be an issue.
Start.
All right, so now that we've corrected our flash drive issue, we once again just pull up our programs by hitting list program, then we'll scroll over here to USB. So there we are. Now we're looking at all the folders in the USB that we insert in the machine. We'll select the one that has our program in it, hit the arrow to go over, and now you can see the 4 actual programs that actually are required to finish this actual part here. So what we'll do is we'll begin by selecting the first one, which here is facing. So we're highlighting that program. We'll hit select program. It brings over here. So to go over here to look at it, we hit memory, and it brings it up over here in our actual machine what we're going to run it as. So we can see in here we're using T101, which is tool 1. We can also see that we're using G54, which is what we set our work shift offset. You just want to verify that. And we can also see some of the feed rates we're using. So in this case for aluminum, here in this line that says N21, it says G96, which is constant surface feet per minute. And we're using a constant surface feet per minute of 350. And our feed rate down here, we can just verify that is 0.005, 55 revolutions or inches per revolution, which we just want to check to make sure it matches what we programmed at, so we know we're not going to do any damage. So now we're ready to run it, so we'll just adjust our coolant, make sure we get proper, hit our tool where we want to, and simply we'll make sure we're at 5% rapid once again, and at the top of our program, and we can go ahead and hit cycle start while holding feed hold and spindle stop just in case something goes wrong. So we see it comes over. We're going to watch to make sure it does what we want it to do. So we see it goes in and faces the part. Alright, and then that program is now done. So now we've successfully faced our part. We can now load up our next program. So once again, you go list program, we'll go highlight down here to roughing, select program, hit memory, and now our program's up there ready to run. Make sure we're on the right tool and our coolant is on the actual tool itself. And now, once again, make sure we're at 5% rapid, just in case it tool changes, we'll make sure we're clear. And then we'll go hit cycle start and hold feed hold, just in case something goes wrong. Now as the machine's running, we want to watch to make sure the actual turret itself's not going to hit the spindle, the tool holder for this drill and tool 4 is not going to hit the chuck, and we're going to make sure that we're just not going to do any damage to the machine itself. So just constantly watch it, make sure you're not going to hit anything. Alright, we're almost done here. Now the machine's going to retract and go home. Alright, and there we can open the door and we'll check and we can see there's our finished part. Alright, so after completing our first roughing cycle, we wanted to actually check to make sure our machine's cutting accurate to what we zeroed the tool in the X diameter. So what we did here is we know this part should in the end be 0.5 inches in diameter. However, we left 20 thousandths radially stock to leave on it, so it should read 0.54. So in this case, it's slightly off, and it's reading 0.539. So what we'll do is to correct that and make sure the machine is completely accurate to what we're wanting to cut at, is we'll go over here to MDI, and we'll erase our program, type in G00, G54, T. In this case, we're using tool 1, and we want to correct tool 1 to make sure it's accurate. So we'll do T101, and then we'll want to send it to the X diameter of what it should have been cutting at. So in theory, it should have been cutting at 0.54. So we can verify that by going to edit here, or going back to memory, and we'll scroll down here. to where we were cutting our very last diameter, which we can see right here was 0.54. So it says in this line of G97, it says G3, X 0.54. That's where it was cutting at, and it thinks it was cutting there. So what we'll do is we'll go back to MDI. We'll type in our code of G00, G54, T101, like I was saying, and we'll tell it to go to that spot of where it was cutting. So X 0.54. All right. Make sure the machine is clear because it's going to now go in on the X direction. And we will send it there. All right, so now if we were to, in theory, jog this machine over, all the way over to here, it would be exactly touching this part. So this eliminates any error that was in that feeler gauge when we were zeroing it off. So what we'll do now is we'll measure this with using our micrometer here. And we can see it's just a little bit off. It's 5.396. So what we'll do is now that the machine is cutting at that same diameter, or is sitting at the same diameter of which it was cutting at, we'll once again hit X diameter measure, but you got to be in handle jog, my bad. Hit X diameter measure, and we'll type in the diameter of which we measure. So in this case, it was 0.5396, and hit enter, and it now corrected any error in the machine's 0 of tool 1. Alright, so after making sure tool 1 was accurate, we'll start running our finishing passes. So we'll select our first one here, which is going to leave, once again, 10 thousandths stock to leave radially. So we once again make sure 5% rapid, our coolant's in the proper spot, we're not going to hit anything, and we can go ahead and hit cycle start. And holding feed hold just to make sure if something goes wrong, we'll watch it come in and start cutting the part. Now, as this part here was leaving 10 thousandths radially stock to leave, it should read a diameter of 0.052. So once we're done here, we'll measure it and just make sure we're accurate. So we'll grab our micrometer. All right. There we go. So there we are spot on. So from there, now we can go ahead and run our last finishing cut. So we'll once again go to list program, highlight our next program, hit select, go back to memory, and we can see that is our program once again using tool 1. So we'll hit 5% rapid, start our program. Alright. So there, now we have our part, of which is now should be exactly to our final diameter of 0.5 of an inch. So we're spot on. Now from there, we can simply go ahead and start our threading operation. Now to do that, we're going to go ahead and need to change the tool 3. So we'll go to MDI, type in T3, shut our doors, make sure 5% rapid, and hit turret forward while holding stop just in case. And now we are on tool 3. So now to set up our actual threading profile for tool 3, we're wanting to do a 1/2 inch by 13 thread. So we'll go over here to edit. We're going to use the machine's internal programming system called VPS, which is virtual programming system. We'll scroll down here to VPS, select that one. Now we're wanting to do outer diameter operations, so we'll select OD turn. And then we want to do OD thread, which is the operation we want to do. So we'll select that. And now here is where you'll input all your parameters. So like for instance, we're using tool 3, so we put in 3, enter offset 3, using work offset G54, which is what we set our zeros at. We want coolant turned on, so we type in 8. We want a clockwise thread, so we select 3. We want 13 threads per inch, so we'll type in 13 decimal here for threads per inch, hit enter. We'll type in our major diameter, which is in this case is 0.5, and then it automatically programs our minor diameter. But however, I'm going to alter that to what our chart says for this part. So we'll go 0.404, hit enter, and now it tells us the calculated thread height, which is 40 thousandths. First pass depth of cut, this is how deep each depth of cut is going to be. So in this case, we want to do about 7 thousandths, so 0.007. Type that in. Next is flank infeed. 59 is default. It's recommended. Thread length. Now this is the length of the threads of which we want. So in the case of our part, we want the threads to be a total length of 1.1 inches. And then we want to select a 24 chamfer retract, which is the standard style of thread. We do not want a thread taper, so we leave that at 0. Surface feet per minute. This is the actual RPM of what we're running it at. So in this case, we'll select 100. So that'll automatically set the RPM at 945 RPM. 0 start point. So now this is the actual start point relative to our G54 offset. Now, if you remember, we faced off or exactly 50 thousandths from where we set our 0. So in this case, we need to type in negative 0.05. So negative 50 thousandths to offset that stock that we no longer have. So we'll type that in. The Z approach, these are where it slows down of when it rapids, so we'll leave those at its default setting. And then we want it to retract when it's done, and we want it to end with the M30, so we'll leave it at that. So now that we're good, we'll once again just hit up here where it says run an MDI. So it's going to output it over here into our MDI program. And since we had the doors open, the machine did not start. So now that we're ready to thread, we'll go ahead and shut our doors, adjust our coolant, and make sure we're ready to run. So we'll look here at our program. We'll simply just look at it. We can see our start length, which is 1.1, which is how long the threads are. We're running 13 threads per inch, half-inch major diameter. We have the correct tool programmed in here. Our RPM is set correctly. Our depth of cut is 7 thousandths, and our start position is negative 50 thousandths. Now in a threading cycle, you can't stop it in the middle of a thread simply because the machine reads one line at a time. So it's going to finish that entire threading cycle before you can stop it. Now, so simply, if you do come in the case of emergency, is if the machine's going to crash, you need to hit the emergency stop, because that's the only thing that will stop it in the middle of the threads. Feed hold, it will continue to thread until it's done. Spindle stop, it will not stop the spindle either. So when I'm running threading, I always have my hand on the e-stop just in case something goes wrong and you can hit it. So as always, we'll start with 5% rapid, and we'll go ahead and watch our program. So I'll go ahead and hit cycle start, holding the emergency stop just in case something goes wrong. We'll hold our, and there we go. It does multiple passes at different depths, and we'll just let it keep going. And once again, during this whole process, I just hold the emergency stop just to be sure if something does go wrong. as you can see, we now have a thread part, and we can fit check this with a nut, and we'll see if it's good to go.
Okay.
All right, so now that we completed our threading, we need to actually do a tool change here for actual, to put our parting tool in. So what we'll do is we will handle jog it over to where we don't have to lean in the machine as much. And we'll grab our part off tool and our Allen keys, and we can go ahead and begin removing tool 3.
I'm ready. All right.
All right, so now we got our parting tool in here. Just make sure it's tight. Simply just snug each bolt down. They don't need to be crazy tight. Just tight enough to make sure it's in there. So the first step is, now that we did a tool change on tool 3, we actually need to re-zero this tool. So how we'll first do that is we'll zero our Z. Simply we'll do that by touching off of our touch off tool once again. So you put your touch off tool back in. We'll keep scrolling over. And then we will go once again until we see it touch off the light, and keep going into a smaller increment until we reach the finest increment on the machine of 1/10,000th of an inch. So,
Watch your hand.
oh, there we go. So there's the very first increment to where the light turns on. So when we first see the light come on the 10,000th increment, once again we'll hit Z face measure, making sure we're highlighting tool 3's Z offsets. So hit Z face measure, see it change that number. Now, once again, as we were doing earlier, we set our X diameter zeros. We once again need to do that, but for this tool. So here, we'll come once again, grab our feeler gauge, which in this case is 12,000ths of an inch thick. We'll scroll in to the actual machine surface of the bolt. Once again, get really close and keep going in finer increments until it starts to drag. So we start getting dragging, so we'll go to a smaller increment. Alright, we can see it starting to pinch the feeler gauge, and you can start to feel it. So now, that is perfect. We can't fit our feeler gauge in there anymore, and we're just starting to pinch it. Alright, so we'll pull our feeler gauge out, we'll grab our micrometer, and we'll measure the diameter of that surface. Alright, so we'll measure our diameter, which is 0.848. Okay, so our micrometer measured that diameter of the stock being 0.848, and our feeler gauge being 12,000ths of an inch thick. So 0.848 plus the actual 24 thousandths is what we'll type in to our X diameter measure. So the machine has not been moved since we touched it with the feeler gauge, so we'll hit X diameter measure. We'll type in the diameter of what the micrometer measured plus the 2 of the feeler gauges, so which is in this case equivalent to 24 thousandths of an inch thick. So if it's 0.848, and then we can type our thickness of our feeler gauge, and we'll input that in as well. And now that tool is zeroed. Alright, so now we set this tool in the X diameter and both the Z, we're ready to run. That's the benefit of using that touch off tool. It makes it really easy when you have to do on the fly tool changes in the middle of a part. So now we'll make sure, once again, we'll back off the part, move it over to a safe location, we'll adjust our coolant, once again, shut our doors, and then we can load in our parting operation. So we'll go to our last program here, select our program, go to MDI. So we can see up here is it left our comment of that we're parting in this operation. We're using tool 3, which is the tool that we just input, so we know we're in the right tool. We can check our feed rate here and our surface feet, which both match of what we programmed. 2 thousandths per evolution and 350 surface feet per minute, which is ideally what we want. And we'll hit 5% rapid once again. Make sure we're in a safe location if it accidentally tool changes on us. And we can hit cycle start. and what the machine will go over, and it will start doing parting. Now when you're parting, you want to make sure you don't hit the tailstock or the actual chuck itself, and we'll just let it finish off, and our part falls to the bottom of the machine.